In basic probability problems, we're not always given the total number of outcomes. In these cases, we must determine the total number of outcomes from the problem statement. So let's look at some examples. We want to find the probability that when a couple has 3 children, they will have at least 2 girls. Okay, so we need to start by determining the sample space for this problem. So the sample space would be all the possibilities when a couple has 3 children, right? So they could have 3 boys. Or the first 2 children could be boys and then they had a girl. Or the girl could be the middle child. Or the girl could be the oldest. Or the first child could be a boy and the second 2 children are girls. Or the boy could be the middle child. Or the boy could be the youngest. Or they may not have any boys at all. Okay, so we want to make sure we've covered every possible outcome. We've got boy, 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 girl, boy, girl, boy, girl, boy, boy. These are all the possible ways to have one girl in the family. Then boy, girl, 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 boy, girl, 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 boy. Okay, so we see the 2 girl possibilities, and then girl, girl, girl. Okay, so we want to find the probability that when a couple has 3 children, they have at least 2 girls. So the probability at least 2 girls. Okay, well, that's going to be the number of ways to have at least 2 girls over the total number of different simple events. And we've listed those in our sample space. Okay, this is the classical approach. And we are assuming that the probability of a boy and the probability of a girl are equal, and therefore each one of these outcomes is equal. That's commonly done in textbooks and studying probability, is to make that assumption. It's close to that anyway. Okay, so let's think of this. The number of ways to have at least 2 girls. Okay, let's see. There's no girls there. One girl, 1 girl. Here's 2 girls. That's an example of 2 girls. That's an outcome that has 2 girls. Here's an outcome with 2 girls. Here's an outcome with 2 girls. But this doesn't say 2 girls, it says at least 2. So if you have 3 girls in the family, you have at least 2. So the number of ways to have at least 2 is 1, 2, 3, 4 ways out of the total number of different simple events. Well, we had 1, 2, 3, 4, 5, 6, 7, 8 simple events. So this would be a probability of 1/2, or as a decimal, 0.5. Okay, so we had to come up with this number of ways to have at least 2 girls, and it helped to look at the sample space. And you saw I sort of had a pattern going here to help myself make sure I got every possible outcome and I didn't duplicate any outcomes. So I kind of had my idea of how I would do a pattern by introducing 1 girl and then moving that 1 girl through the family from the youngest to the oldest, and then introducing that 1 boy and doing the same thing. Okay, another similar example. Let's see. We want to find the probability that when a couple has 3 children, they will have exactly 2 girls. Okay, so this time it's the same sample space, right? The couple with 3 children. So the sample space hasn't changed, but now we want them to have exactly 2 girls. And we saw that happened here. 2 girls, 2 girls, and 2 girls. but we wouldn't count the last one that time because 3 girls is not exactly 2 girls. So the probability of exactly 2 girls would be the number of ways to have exactly 2 girls. And we saw the number of ways is either the 2 girls are the youngest, or they're the oldest and the youngest, or they're the 2 oldest. So there were 3 ways that you could end up with exactly 2 girls over the number of different simple events. So this time, this equals 3 out of 8. And that would be, as a decimal, 0.375. Again, it just depends on what you've been asked to do with your results. Either show it as a fraction or as a decimal. Okay, so we had to come up with these number of ways by looking at the sample space in those 2 examples. Let's look at another one. Okay, so Starbucks customers arriving at the drive-through window were surveyed to determine how often they visit the coffee shop, and they were given 4 choices of answers. 65 customers said weekly. 142 said, we'll circle that, 65 said weekly. 142 said bi-weekly. 63 said monthly, 63 monthly, and 48 had less frequently than monthly. There's 48 right there. Okay, find the probability that a randomly selected Starbucks customer visits the coffee shop weekly. So we would say that this is the probability of a weekly, I'll just call it weekly, customer visits the coffee shop weekly. And this would be the number of times A occurred, or number of times weekly occurred, all over the number of times the procedure was repeated. Okay, so we know how many times weekly occurred. It said 65 customers said weekly. But now how many times did they repeat this procedure? So we have to figure that out. They didn't tell us. But they did say that they asked these customers as they came through the drive-thru, and these were their responses. So if we add up 65, 142, 63, and 48, that's the number of surveys that were taken, or the number of times the procedure was repeated. So let's add that up. 65 plus 142 plus 63 plus 48. And I think that comes out to 318. So going back to our probability, then we could say the number of times weekly was the response, 65 times, that was our response of weekly. The number of times we ran this procedure, or the number of surveys we took, were added up to 318. So again, if we're asked to give that as a decimal, we'd have 0.2044, something like that. It just depends, and we could be asked to round that to 3 decimal places, something like that, or leave it at 4 decimal places. Okay, but But in this case, they did not tell us that denominator, right? We had to figure that out by adding up the total number of responses that were given for the survey. Okay, so it's important that we are able to determine these number of outcomes, and depending on the problem, there are different ways to do it. It often helps to create the sample space, as you saw in the first example. And so keep that in mind when looking for the total number of outcomes.